So this is introduction for digital signal processing. The course number is ELE 650. So it's graduate level class. Instructor is Li Chuan Liu. You can call me Dr. Liu, and electrical engineering department. So I believe you have the syllabus, right? And here I just want to go through some important things for this class. Okay, so objective, I just want to review. We want to do two things. First of all, we want to know about the theory, so background for signal processing theory in digital world. Second, I want to you guys and girls know how to design and also implement DSP methods algorithms by using MATLAB. Other programming languages is also fine, for example Python or C, C++. So I do have a required textbook, discrete time signal processing, second edition, third edition, either one is fine. Grading policy, so 20% to assignments, 40% for a term project. I will ask you to present and also hand in the written report. You can find more details in the syllabus. Okay, we have a midterm exam, 40%. Okay, so assignments, I'm going to post problems in Blackboard, and I will also provide solution. Okay, besides the textbook, there are also some reference books you can take a look. Okay, yeah, let me know if you have any questions. So something I'm going to cover in 650. So first we talk about discrete time signals and systems. Then we talk about important tool can analyze discrete time signals, Z-transform. Then we talk about sampling of continuous time signals, transform analysis for linear time invariant systems, LTI systems analysis by using DTFT and also Z-transform. Yeah, we're going to talk about the details for all the transformations and how to use those transformations to analyze signals and systems in details in following lectures. Discrete time signal, discrete time systems, different structures. Then we talk about how can we design filters. Then DFT, discrete Fourier transform, and how can we calculate DFT more efficiently, fast Fourier transform, FFT. Okay, last one, we're going to talk about some applications of digital signal processing. Okay, so starting, talk about electrical engineering systems. Engineering systems in electrical, including pretty much 5 different areas. So communication, signal processing, control, power, and computer systems. So communication, long time ago, people use nothing right with electrical engineering. So people use light, smoke, fire, right, flags to communicate with each other in long distance. And right now, right, people use electrical engineering systems to communicate. For example, right, like cell phone, telephone, Bluetooth, walkie-talkie, satellite, right, communication. This is pager, right? Pager for physicians, right? They still use it, but otherwise, right? Generally, people use cell phone, right? Not pager anymore. Okay, this one is a pretty old devices, right? And you may not see it in our daily life. Maybe only you can find it in a museum. This is a telegraph machine. Signal processing systems process signals, right, in our daily life. For example, your cell phone, right? Digital camera, camcorder, audio processing, right? Music system, communication system, navigation system. So the one common thing for all those different kind of devices and systems, they have same, right, important component we call it digital signal processor, DSP. So you may have very high-end signal processor, right, like in cell phone, and sometimes not very sophisticated one. For example, in those audio, processing system, you can use a controller, right, or microcontroller or microprocessor. So depending on different applications, right, we can use different levels of processor, and even for same processor programmed in different way, you can do different jobs. Control system is also one area of electrical engineering. For example, you can control motorcycles, right, or vehicles. Control temperature, right, inside this building, inside your home. Control temperature inside your car. Okay, one really important subsystem is power system. So no matter what is your device, no matter it's for communication or for signal processing, power system is one must, right? It's something you must have. So for example, battery, right, change chemical, right, energy into electrical. Power plant change like thermal, right, or mechanical energy into electrical. And this motor, right, change electrical energy into mechanical. And transformer can change the voltage, right, in order to transmit electrical power from one side to the other side. And the computer system also considered as one area of electrical engineering. So you may find very high performance computing devices, right, with many machines working together, and some really small size, right, a chip, right, is also a computer system. Daily use like laptop, right, desktop or iPad. So in many applications, you can find a couple of systems and maybe all of the 5 systems working together. For example, right, in your cell phone, you'll have communication, right? You'll have signal processing, you have control, power, and also cell phone itself is a pretty high-end computer system. So in many different areas, right, those 5 different systems working together. Okay, so signal processing system actually is in your daily life, right? You can see it everywhere, like we mentioned. Those different applications, right? You use it every day, right? Every day.